12. A number of 1 Newton horizontal forces are exerted on a block on a frictionless horizontal surface. Which top view diagram shows the forces producing the greatest magnitude of acceleration on the block? Okay, so each of these pictures is of the top view of a block. So there's a force. If you were to view it from the side, if this was our block, there would be and this is on some surface, right? There would be a downward force due to gravity, and then there would be a normal force counteracting that gravity, and the two would balance out, and the block would be free to move horizontally, but not vertically. But we're looking at the block from the top in each of these pictures, so the force due to gravity is actually into your screen, and the normal force is out of your screen, and those vectors are not shown in this diagram. We're not interested in them because what we want to know is about the forces that are producing acceleration on the block, and the block isn't moving vertically up and down, it's moving side to side. But within that plane, side to side, there are still 4 degrees of freedom, right? It can move, in this case, left or right, and it can also move back and forward. So since we're viewing it from the top, it's up, down, left, and right. So hopefully you can picture that spatially. There's 4 ways this thing can move. And what they want to know is which diagram shows forces that would produce the greatest magnitude of acceleration. Well, what does the acceleration depend on? Well, it depends on the net force, right? F net equals mass times acceleration. Presumably it's the same block, so the mass, regardless of whether it's 1, 2, 3, or 4, is the same. So that's not really having any effect. And the acceleration is going to depend on the net force. So which of these scenarios has the maximum net force? Let's eliminate 2 right away, because you have a 1 Newton force dragging it up, a 1 Newton force trying to drag it down. Those are going to counteract one another, and the net force will actually be 0. So that's not going to be the maximum. And even though 4 is a little more involved, again, the vertical forces counteract each other just like in 2, and the left and right forces counteract each other. So again, F net equals 0. How about 3? In 3, the vertical forces counteract each other, so there's no net motion in the vertical direction, but there's nothing to counteract this 1 Newton force to the right. So the net force is going to be 1 Newton to the right. And I'll put this little arrow. It's nothing formal here, but I'm just reminding myself that it's a 1 Newton net force to the right. And what about over here? Well, we have nothing to counteract this 1 Newton force to the right, so that certainly will affect the block. And we also have nothing to counteract this 1 Newton force down, so that will affect it as well. So what is the sum of these two? It's not 2 newtons, right? Because they're not acting in the same direction. How do we add vectors? We have to add them vectorially, right? So we add them head to tail. So this is the force to the right, and this is the force down, and they're each 1 Newton. And then the net result of that is the hypotenuse of that. So if this is 1 and this is 1, then this is going to be root 2. Did a little Pythagorean theorem, right? If this is a right angle. Anyway, it's greater than 1, that's for sure. So the net force here is, let's say, approximately, and you can check this in your calculator, it's going to be roughly 1.41 newtons. And if you wanted to imply a direction, it wouldn't be to the right, it would be down and to the right. So, you know, if this was cardinal coordinates with north being up, you could say it was southeast, whereas this is east. And the best choice is 1.